Okay, everyone, welcome. I'm very excited today to talk about plumbing. When I started getting this ready to talk about the things that we need to know as supervisors, I thought it would be pretty short, pretty simple, but as I started looking through our old pictures and some of the things that we've worked on in the past, I realized there's really quite a lot to know. There are a lot of things about plumbing that are a little bit more complex than you might have thought. And I'm very excited that Cameron Dressel is here. We've been working with Cameron for over 20 years, and he's just a great partner. His whole company is full of conscientious and knowledgeable people. Cameron's taught us a lot over the years about better ways to do things, and always does a great job for us. So it's really great that he could come join us today. Thank you, Cameron. So let's talk about why plumbing matters. There's two important things about plumbing. Probably the first and most important one is you can actually cause serious problems with people's health if you mess up with the plumbing, right? Like sewage is very important to deal with properly. The plumber does protect the health of the nation, and it's one of the few things we could screw up that could really hurt somebody. So it's important to get that part correct. The other thing that is important is that supply line that has an unlimited supply of water on the other end and gets a hole in it can cause an unbelievable amount of damage. We've had a couple of issues that cost over $10,000, and I've heard of ones that were $50,000 or $100,000 or $200,000. You can just picture a flood that happens when someone isn't around to watch it. So it's very important that we do everything we can to minimize the chances of that sort of thing happening in one of our houses. You never want to pull up to one of these beautiful houses like this and go inside and see this going on. Clients don't like it. We don't like it. It's much better to do everything we can to minimize the likelihood. So this is somewhat arbitrary, but I've kind of divided up the things we're going to talk about today into these groups, starting with probably the first thing you have to think about for plumbing and going on through a whole bunch of other things that we've learned over the years. Let's start with this first one. Drains have to be planned out well, or you end up like whoever did this job in Georgetown did. They just cut all the joists out of the way and ran the drain line in, and just drastically reduced the strength of this floor. We don't ever want to be in that position. So when we do a renovation or when we plan a new house, we want to make sure we have it thought through where all the drain lines are going to go, especially the big ones, right? So the first thing to know is they all have to be sloped, and there is a minimum. It's not that much, 1/8 of an inch per foot, but we do have to hew to that, and it's especially important, as we said, for the larger lines. It's just not a whole lot of room to play with on these, so it's important to think that through before you really get going, even on the framing. As I say, these are usually the priority over the ductwork, electrical, and supply piping. Those are all usually a little bit more flexible, even though we usually have the duct people come in before the plumbers start working. It's important to know where those drain lines are going so the duct people don't get in the way. Every once in a while, it's also important to know if you have recessed lights, bath fans, or specific duct locations that have to be followed for the design of a room or whatever. It's important to have those laid out so we don't accidentally put the drain line in the way of them when we could have put the drain line somewhere else. So it's good to have a meeting ahead of time and think through all these things and make sure there's space for everything. You like to have that first thing, right? Get in there and take a look at where the drain lines are going to go.
Yeah, so I mean, there's certain things you can do, like first you have to figure out your toilets typically, you know, and your toilet flanges. You might get in there and just install those before the ductwork starts, because that's going to obviously, that's dictated. That's where the toilet's going.
Right, you can't move that.
Other things like shower drain and stuff like that.
Okay. Gotcha. So maybe even go and do some work for a day or two before the duct folk get there.
Right.
Gotcha. Another important thing to know with drain lines is there is a good chance we're going to have to be doing a clean out on them at some point if they ever get clogged. So it's important to have a way to access those. It's important that they have instead of hard 90-degree turns, whenever possible, we should be using 45s or sweep 90s so that it's easy for us to snake the drain clear through the pathway. And we don't have to open up a clean out and empty out many gallons of sewage just to be able to clear the drain. So it's better to get it all straight. And vent lines also require a little bit of planning. So we'll talk a little bit more about that later. There's a couple other categories of piping that, again, we don't necessarily have a lot of room to deal with. Exhausts from gas burning appliances, those usually have to all slope in one direction. There's a lot of different directions I have on here. Read the manual. It's important to know where they have to come out. Usually if there's an inlet and an outlet, they have to be next to each other. The reason that I have a picture of this is because we had to raise it above the snow line. This was not a flue that we installed, but this system was on a house we renovated. It turned itself off in a snowstorm, so we came out and extended it upwards so that it would be above the snow line. Things like that are important to know, and again, it requires us some planning ahead of time. One other interesting thing we've had with some of these flue lines, when PVC heats up, it changes size, so it gets longer, and then when it cools down, it shrinks back. And that can, if you have a long 30, 40, 50-foot run, it can make creaking sounds as it goes through the framing, unless you isolate it. So it's much better to have a short run if you can. And if you do run the line through the master suite wall and it's annoying the clients, you can get up in the attic with a can of silicone spray and make it not creak as much, but don't tell anybody I said that. It's much better to plan it out, not in the master suite wall. And again, another type of piping that's better to run ahead of time and plan out is your radon vent. These are required in 2 of the jurisdictions we work in, and they're talking about adding it in Washington, D.C. as well. So a radon vent is just a 3 or 4 inch pipe that goes from below the slab all the way through the roof. And one quick thing on that, it's much better to do what it says here in this drawing that came from the EPA, put a T on the bottom of it and stick it into the slab separate from the sump pump. That way you don't have to disassemble it every time you need to service the sump crop. So it's cheaper and easier to do it this way. We want to make sure it goes up through the roof because it does act as a passive vent even without a fan attached to it. And it's best to put it through an accessible attic because if they do have a radon issue that requires a fan, you can put the fan in the attic. And that way it's pulling air out through the house. There's no positive pressure on that. You don't want to put the pump at the basement level and have the tube be pressurized where any leaks would go into the house. You want to have the fan at the top pulling air up through the tube. So if you can, put it in an accessible attic with a junction box, and then we're all set for if it's needed. All right, so that's it for drain planning. Anybody have questions or comments on that? Okay. Okay, so a few things we should know during the framing phase. The first is all of our showers should have either on the plans or a sketch from our supplier. We should know where all the valves are going to go, at least roughly. And we want to make sure we frame the area with a stud bay and then centered on that so that all the stuff can go in the middle and the studs aren't in the way. Right? So we're going to check our sketches and center a bay where all the valves go, just like Judd did on this one. Venting gets a little bit complicated when you have a really big medicine cabinet. So this is also on a job Judd did. He boxed out for the medicine cabinet before the plumbers got there to run the vent so we could run the vent in the correct place and not be in the way. For islands and when there's a sink in front of the window, it's also important to think through how that's going to go. If you have a bearing 2x4 wall with a big window and 4 bearing studs on each side, the venting for that sink is not going to be able to go sideways through the wall and around the window because you can't put a 2-inch hole in a 2x4 bearing stud. So we'll have to have a different plan for that. And as Cameron was saying, probably the number one thing is where the toilet is going to go or a bathtub, the joists have to be out of the way. So we got to know where those are going as we're framing and put the joist somewhere else. A lot of our designs, the shower drain has to be exactly in the middle of the shower, and again, we're going to have to make sure there's no joist right there, so we'll plan that out too. And as Cameron and I were joking around, you could do an hour discussion on how to build curbless showers and leave out everything else about plumbing. We're not going to do that today, but it's very complicated. Let's sort that all out in design. So unlike the folks who hacked up those joists on that house in Georgetown, we're going to pull the directions or look in the code book for where we can cut and notch joists and follow those rules. They're pretty straightforward, and especially with I-joists, you can cut some really big holes, much bigger than you might have thought. If you need one bigger than it shows in their guidelines, sometimes we can call their engineers and they'll give us permission to do an even bigger one. So that's good to know. We'll just make sure we don't damage anything. One other framing phase issue that sometimes comes up, a lot of bathtubs, most bathtubs require a 2x4 across the wall at the back for the back of the tub to sit on. And if you don't do that, then in 3 or 4 years you get a phone call that our bathtub's falling down and the caulk is failing in our bathtub, and it's because there's nothing holding up that end of the bathtub and it's just falling out off the wall. So let's make sure we get that block in there. Again, read the directions. Some plastic tubs do not require them and others do. Here's something that we've been doing a bunch of lately is the wall hung toilets. Who's had one of these on their job lately? Probably just about everybody, yeah. Read the manual. They're all different. This one is a 4-bolt commercial style, and it supports the piece that's hanging off the wall very well. It's supported high and low. But a lot of the residential ones like these, particularly this one on the left, you can see it only has 2 bolts sticking out of the wall. So the China piece is kind of hanging on those 2 bolts, and it can hinge and push downward. So there's a lot of pressure at the bottom of it. And we've found with these kits, if it's just drywall running across in front of it, it can actually push into the drywall and damage it. So we're going to want to either put full blocking behind those, or we're going to tile that wall like we've done on some jobs, something that's stronger than just drywall. They're pretty neat though. I was the first time we did one of these many years ago, I was really worried about how do you work on the insides, but it turns out that you just pop the push button plate off, you can actually reach in there and pull it all out. Go ahead, Judd.
Just a sheet of plywood?
You could do a sheet of plywood. Yeah, under the drywall? Yeah, as long as you had the clearance, or you can run a block between the legs. Yeah. Yeah. I mean, I think on your most recent job, we tiled the wall. I think the tile's going to be strong enough. Yeah. And you use the ones on the right, which you can see has those vertical legs in the middle that are much closer. I think those will hold up just fine. Okay. Any questions on framing? All right, so the insulation phase interacts with plumbing in a couple of places. Really, in a perfect world, not very much, but we'll talk about that in a minute. One of the most important and things that happens on almost every job is we end up having a tub or a tub deck that touches an outside wall. So when that happens, we want to make sure, because fiberglass or other fibrous insulation doesn't really work well as insulation unless it's surrounded on all sides by an air barrier, we want to make sure we get the air barrier between the outside wall and the tub area. So this is not done correctly yet. You can see we're looking straight into the stud bays. By the time that tub deck is framed, we should have insulation in those stud bays and an air barrier across it. An air barrier is something like OSB, thermoply, drywall, any sheet material like that will work just fine. So this is what the guys did on that job. They corrected it. They put a sheet of OSB between the tub deck area and the outside wall, and they filled up the stud bays with insulation. So very nice job, exemplary. Nice. So that's how we're supposed to get it done. If you just have a bathtub, sometimes a sheet of thermoply is easier to deal with because it's so thin. It's only about an 1/8 inch thick. So you can just put that on the wall before you put the tub on that horizontal ledger holding up the back of the tub. All right, so as I was saying, it's better if we just don't put pipes on exterior walls. When ice forms in a copper pipe, I was just reading a thing, some engineers actually measured the pressure inside the pipes and that they put in a freezing chamber in a lab, and it went up to 4,000 psi before the pipe blew apart. So that's an incredible amount of pressure. There's really no resisting the freezing power of the ice forming in the pipes. So we really have to not let the pipes get that cold. In fact, we've decided that it should be a warranty exclusion if we ever have pipes in an exterior wall or floor or ceiling, because it's 100% dependent on the house being heated enough, which doesn't happen if the power goes out or the furnace breaks, and 100% dependent on the temperature not going much lower than we're used to, which I think 4 years ago it went to -2 at Dulles, which is like 10 degrees colder than I've ever heard of. So you just don't know what the weather's going to do or what the power grid's going to do. So if we're going to put pipes in an exterior assembly, it's going to be a signed warranty exclusion from the clients. So we're trying not to let them do that. Sometimes they will, though. And this is what not to do. These are pipes. They are close to the drywall. We cut a hole in the attic, and we're around behind a laundry room looking at this. But all that was in there was fiberglass bats, and air just convects through fiberglass bats unless they're super good air sealing job on all sides. It's just not good enough. So if we ever do have to put pipes in an exterior wall with that warranty exclusion, what we're going to do is put in 3 inches of foam insulation that's fully air sealed, that makes a completely air sealed chamber or box around the pipes. So this is an example of a job that Alex and Charlie both worked on this one, but this is one of these showers that has lots of body sprays, and each of these stud bays has been filled with insulation that's been fully air sealed. So the pipes are relatively protected, as long as the heat stays on. And this is another example of it. Cameron, you were pointing out that even if the insulation works, there's still a whole other issue with this, which is servicing it.
If that's an exterior wall, exactly.
Yeah. I mean, how do you replace that valve body if something goes wrong with it, which is going to happen in the next 30 years, and parts may but probably won't be available? I mean, you were saying you've actually cut through the outside of houses just to get to a valve on the wall.
Well, yeah, it came down to, did they want to cut the tile in the shower?
Yeah.
Or did they want to cut the outside of
Cut
the
the
house?
outside wall, yeah.
Yeah, which was,
Yeah.
for whatever
So
reason.
which one of your guys was up on the ladder cutting out the siding? That's what I want to know.
No, it was done by the contract.
Okay, yeah, that makes sense, because I can just see Junior looking at me when I tell him he's climbing up to cut out the siding. So again, if we don't want to do this, but sometimes this is probably the most common situation for us. We're doing a bathroom above a garage. We have to box in the pipe run, either with foam board like this, and this isn't air sealed yet. Obviously, there'd be a lot of can foam all over it. Or we have used spray foam to deal with this situation too. Yes, sir?
Are there certain pipe materials that work better than others?
Great question. Why don't you
Well,
answer that?
I mean, PEX, which is the product we prefer to use,
Right.
is basically, it'll freeze, but it won't burst.
So yes, PEX is
Yeah, I mean,
better.
it would be the choice in that situation, and then
Now, have you ever seen
at
it?
least you're not going to have the water damage. You might have the inconvenience
Right.
of the pipe freezing and not being able to use it.
Yeah, so that one where we were looking at the back side of the wall and there were the white PEX lines, those froze, but nothing bad happened to them. However, I don't know if you've seen this, but the fittings themselves can either get pushed off the pipe or can break.
Right. I mean, in that situation, you have the brass valves and stuff, so you still. But if you were running a 3/4 inch main through that soffit or whatever it is, and it was PEX, there's no fittings. It's
Right.
You're pretty much.
So there you go. PEX is or doesn't get damaged as easily by freezing, but there can't be any fittings on it in the freezing area or valves or anything else, so it wouldn't really apply to those showers. Yeah. If you have a vanity on an exterior wall, this is an easy trick to do. I hope we're going to always do this. Run the pipes up through the floor in the heated area instead of going out into the freezing cold wall and back in. Same thing with toilet supplies. Most toilets you can bring the supply up through the floor. We're working on a renovation recently where the toilet pipe freezes every time it gets below like 15 degrees, and so we had to reroute it. Adoni took care of that for those clients. Not a pipe we ran, but one that someone did. They ran right out into the insulation in the wall, and it keeps freezing. So something that folks sometimes talk about is, should you put insulation directly on the pipes, like the round pipe insulation, when they're in an area that can freeze? And my experience with that is there's not much point to it. If the pipe is far enough away from the heat, then the insulation isn't keeping the pipe warm, or it might for an hour or two, but it won't for a day or two. So many of the frozen pipes that we've fixed in customer service had insulation on the pipe itself. I guess there's no harm in doing it, but it doesn't seem to work If it's cold for more than a few hours, you'll still be able to get it to freeze and burst like this. So this is the same pipe, insulated on the left and burst on the right. So I just don't think it works. Yeah.
Yeah, when it's in a crawl space, I think it helps.
Right.
Because you don't have the
Might
heat
only get
from the
cold for a
building.
little while.
Right,
Yeah.
right.
Okay.
But in the wall, your best bet is just try to get a barrier between the exterior wall and the pipe itself,
Gotcha.
and let the heat from the house
Oh, you don't want to insulate the pipe because the heat from the house can't
actually
get to the
help.
pipe?
Right, right.
Okay. And here's something that Elmer did on a job recently. I thought this was really clever. Rather than run up in the attic for 6 hours and play around with foam board and make a little box to run the line in, he just furred the ceiling down a couple inches and ran the pipe in there. So that was pretty sharp. I like that. You got an air barrier above it, insulation above it. It's nice. And we do this a lot, right? A lot of our clients want these rain heads that are in the middle of the shower, and that has to come out of the ceiling. So see if you can get a soffit across the doorway of the shower so we can drop the ceiling a couple inches. It's a good one. All right, we're ticking through it. Let's talk about some stuff we got to watch for work quality. Luckily, not so much with Cameron's guys, but I've got 4 different categories to talk about here. Let's first thing is we should check the layout. I forget who it was who was talking to me recently. They pulled out a level after the plumbers had set all the valves and everything didn't line up. So that's probably worth doing, just as we would with a mason or an electrician or anyone else. Maybe after they leave for the day, pull out the tape and the level, make sure everything's where it's supposed to be. And one other quick thing to check is, and this is important for everyone in design and sales to know, we have to know what the finishes are going on the wall in order to set the valves. Some valves have very little tolerance for the thickness of the materials, so you can't switch from 1/4 inch tile to 1 inch slab or even to 9/16 inch marble without messing up the plumbing. So this is something that we have to know before we can do the rough-in. When you have a handheld, you know the pipe's coming out the bottom, so you got to put it maybe 8 or 10 inches above the bench, not 3 inches. One other thing that happens during the rough-in phase is putting on these temporary stub outs, and it's important to use ones that won't rust. So this is right in our BOWA standard for plumbing. These are really nice brass ones, but they make the plastic ones now, which they cost like 15 cents or something, right? So, and they don't rust. The problem is if you put on black pipe and it's on there for a couple of months or even 4 weeks, it'll fill up with rusty water, and then that gets on your white marble and you're in big trouble. So let's use stuff that won't rust. We don't use white marble. No, when you get out of the shower. The white grout on the ceramic tile. Yeah. Here's another new exciting thing. We've been putting in these, I think this toilet is more complicated than my car. This one, when you walk into the bathroom, the lid opens up and a light turns on and it plays music. I guess it's pretty cool. So we had to put in a plug, which you can see, and that had to be in a specific spot. And the supply line had to come out of the wall in a specific spot. And some of these, it's not really where you would have thought. I mean, you can't see the supply line here, so it must be really close to in line with the drain, much closer than normal. Another quick trick, which I'm sure all of us have seen, is it's best if you know the height of your base tile or base board trim, so that you don't accidentally put the supply sort of right at the top of it where it's halfway on the wall and halfway on the trim or tile. Let's figure that out ahead of time and let the plumbers know how high you want it. The first thing to check is the directions for your fancy toilet. Your toilet flange should be above the floor or at least flush with it. This is shimmed up temporarily so that the tile can run under it and support the flange, and the flange is above the floor so that the wax ring will seal correctly. And Cameron was saying that the easy way to deal with this, what is the best way to do that?
So in new construction, you can always do this, and in remodeling, you can sometimes. We just go ahead and stub up a piece of 4-inch up through the floor, and because I don't know how hard it seems like no matter how hard you try to get that finished floor elevation, it's never exact. So if you have the 4-inch PVC stubbed up through the floor,
right,
you can cut it off flush with the floor.
After the tiles
after
installed.
the finished product's installed.
Right.
And then glue your flange on
Gotcha.
perfectly.
Okay.
But then you have inspectors that want to see that. I just thought about that. Then some inspectors want to see the flange installed during roughing.
Okay.
But if,
As long as you're in the right place, you can just run the pipe
sometimes
up.
we'll just glue
Okay.
a flange on it, and we know it's
Gotcha.
too high, and we can cut it off later.
Gotcha. It's killing me I can't find a picture of this. I know we have, this is what we do in every kitchen nowadays. We're going to have 2 ice makers and a pot filler and maybe a steam oven or an espresso machine. All those things, the shutoff for them can't be behind them, so you have to pull out the 500-pound refrigerator to turn off the water. They got to be somewhere else. And if you need a shutoff, you need it. So the right place for it is where the clients are going to look anyway, which is under the sink base. So for years, we've been plumbing all that stuff to the sink base. Just makes it easy for anyone who's ever servicing anything. Run them all into there, and then they can shut everything off. It's killing me because I have this picture in my head. I was just at a job, and someone had done this beautiful job. All the pipes came up. They had individual valves. They were all labeled, and I can't find the picture, but people have done some really nice work with this. That's pretty straightforward. Again, all appliances, the shutoff needs to be accessible without pulling it. A double stack washer dryer can weigh 450 pounds. It can be really hard to move. It can damage the surfaces if you move it. So we got to be able to turn everything off without having to move them. And Danny came up with a really clever idea on the job he's working on right now, which was he put in a regular dryer box circled in yellow here behind the double stack units that are going to be all enclosed in cabinetry. But then in the sink base, he put in another set of shutoffs that turn off all the water to both units. So that's a really good way to do it. Just add extra shutoff valves if you need to. So this is something that happens a lot with laundry rooms now, right? We're all doing these cabinetry style built-in laundries, and you can't get behind the machine anymore. It's a good idea. Similar concept. We're doing a lot of these built-in in-wall faucets that are mounted behind the wall, and the faucet sticks out for a vanity above the sink. And where do you put a shutoff for that? Well, just stub it into the vanity base and then have a pipe that goes back out from the vanity and up to it. And Cameron, you had a good idea about how to handle the dimensioning for these, right?
Yeah, sometimes it's, as you guys probably know, trying to rough that faucet in prior to the bowl being set, and then having the faucet center with the bowl is almost impossible. And if you have the luxury of just stubbing the pipes up, setting the bowl first, if it's some sort of mirror that's going on there or something, once the bowl's set, you know where your center line is.
Right.
But if it's off an eighth
then you cut open the
inch,
drywall and set the unit.
if it's off
Yeah.
an eighth inch,
Yeah,
it's almost worse than it being off an inch.
that's true. That's true.
And,
Yeah, it's also good to have the trim kit on hand because
Right.
we recently were working on a weird job where it had been roughed in by someone else, and we took it over, and they had centered, there was a single handle and the spout, and they had centered them between them on the sink, so the spout wasn't actually centered on the sink, so it's kind of like someone didn't think it through. Anyway, I like that idea. Put it in later if you possibly can, because then you can adjust that to what you're dealing with. Okay, this is a thing that's come up many times for us. When carpenters put together a fancy set of trim like this is again on a renovation. Adoni just handled all this for a client. Not work we did, but work that had been leaking for 8 years before we started working on the house. You can see down here at the bottom of this column trim, there's some signs of water damage. Anyway, when carpenters put something like this together, they're just going to shoot a bunch of nails almost randomly to get it to all hold together. Same thing with paneling. There's a lot of nails that goes into the paneling that isn't going into the studs. So you can put kick plates on the studs where the pipes cross through the studs, but between the studs where the pipes are, you can still hit it with a nail. And we've managed to do that a bunch of times, or other people. So this one we got a call, there's water on the floor, we take out the paneling, follow it up, and this is what we ultimately find. The highlight of these is the nail goes into the copper and it's kind of seals. it doesn't leak right away, right? You usually get a few weeks up to several years. And then ultimately the nail rusts out or something else happens and starts spraying everywhere. That's what happened on this one. Put up this beautiful, beautiful paneling, started leaking. We cut open the wall, and there are the pipes, you know, right behind the drywall, half-inch behind the drywall. This is a 2x6 wall. Really looking at it, we could have pushed it 2 inches back and wouldn't have had any issue with space in the wall. So that's the takeaway. Have the plumbers run the pipes in the middle of the wall, particularly be focused on this whenever we're doing wainscoting or paneling or anything like that, where there's going to be a lot of random nailing, not through the studs. Make sense? All right. Okay. Talk about a few details of plumbing. This is something that's bit us on a couple of jobs. If you read the Kohler book, the pressure is supposed to be 60 psi or lower for the valve warranty to be to work. That's pretty low. We have a lot of houses that are up to 80 that don't seem to have any issues, 80 pounds per square inch of pressure on their water lines. This house, you can see from the black arrow on the gauge here, is at about 95 pounds, and that doesn't work. This house, all the toilets made noise. It wore out the toilet valves. The kitchen sprayer, you'd turn it on and it would never turn off. It would just keep spraying and spraying. Things aren't designed to work at that high of a pressure. So we need to add a pressure reduction valve, and especially on a renovation, that's one of the first things we should probably check when we go into the house is what's the water pressure in here. If we do add a pressure reduction valve, then when the cold water fills up the hot water tank as you're using the hot water, and then the hot water heater heats up that hot water, it gets a little bit bigger, and if you don't have a pressure reduction valve, it actually pushes water back out to the street. But if you do have a pressure reduction valve, the water can't go out to the street, it just repressurizes the house system. And so we put an expansion tank on the hot water system in a house that has a pressure reduction valve. Otherwise, it can accidentally trip the release valve on the water heater. And you were saying there's a new way to install these?
Yeah, there's a bracket, a wall mount bracket for the expansion tank. So
Yeah.
we'll mount the expansion tank to the wall.
Okay.
So it's not putting a stress on. That's actually not a bad installation there.
Right.
But sometimes it'll be sticking out to the side, and you have all that weight of the expansion tank putting.
Yeah,
And so
that's
then we'll
questionable.
just pipe. It might be 5 feet away. We'll just pipe over to the wherever the expansion tank is. And another good thing is, just like you have that temperature gauge there, it's nice to have a pressure gauge. We try to put them by the shutoff valve when it comes into the house, but the mechanical rooms also, you can just see the pressure.
Gotcha.
You know, you don't have to put a gauge on. You don't.
Right.
And it's a $15 item.
Yeah, they're not very expensive.
Right.
They're so cheap, I have one. Here's something we decided recently we should have as a BOWA standard, that for all master showers, we're running 3/4 inch lines to the shower valves. This is a renovation we did, and it's amazing what passes for acceptable. This is 1/2 inch lines to a fancy master shower for a fancy owner. And you can see they have a buried shutoff valve in here, inaccessible shutoff valve, and they cut a structural stud in half to fit it in. I mean, it's not very good work. So we're going to do better than that. We're going to put the large lines up to the shower valves. So venting is another thing that you kind of have to be a little bit more careful of than I would have guessed until I had a couple problems on my jobs. One is it always has to slope, because there will always be, if you run hot water down the drain, then steam, water vapor will go up the vents, and when it gets to the cold attic, it'll condense, and then it has to run back down. So it all has to slope correctly. If you ever have a trap in your vent, it'll get blocked off. And if you ever have a glue joint that you forgot to do, you can actually get water into the ceiling of your kitchen addition. That actually happened on one of my jobs. I didn't know to check the venting glue joints, and the drain got clogged. They turned on the disposer. It pumped all the water in the sink up the vent, and it poured out into the ceiling. It was kind of cool. What was really cool is they could do it again when I got there an hour later. They showed me how it worked. We sometimes use these Studer vents, they're a little valve thing that lets air in instead of having a vent that goes all the way through the roof. The only issue that I've seen with those is when you put them in a kitchen island and then people use that disposer, it can blow food particles up through the valve, and then it gets stuck open and you can get a sewer smell. So everything else being equal, it's better to use a different type of vent, like a loop vent or a wet vent, that doesn't require one of these. That's just something to think about. We have had some issues with vent pipes going downward because they aren't supported enough. And then not only do you get a trap in the pipe, but it can suck the flashing rubber gasket down, and then you get a little leak. So you got to support the vent right below the roof line. And it's in code that the vent pipe has to terminate at least 12 inches above the roof. So we run into this on some remodels that we do. This is a remodel someone else did and we fixed. This is in someone's kitchen. It looks like the what's now a beam used to be a wall, and I'll tell you why I knew that in a second. But they had this leak that just kept coming back. Little leak, not much, but it would come back every time it rained good. We looked around for hours till we finally started cutting holes in their master closet with all their like Armani suits and stuff. It was a real pain. And we found this. When whoever had renovated their kitchen had cut off a vent, and they put a really nice cap on it, glued it very well. But what they didn't know is someone had put a drywall screw through it about 2 feet up from there. And so after it finally rained enough, the water level got up to that screw hole and poured out every time it rained. So you got to think, just capping the bottom of a vent is a little bit questionable unless you also cap the top, because you will get water in the top. 40 inches a year of rain we get on average. So that adds up. All right. A couple other quick things on vents. On the slate roof, we normally use a metal cap like this that turns in over top of the pipe. But you don't want to do that on your power vented water heater, right? You don't want to hook metal down into there because the steam from that will, can get up behind the flashing if you do that. So what we've been doing instead, this is a little bit half-baked, but if you want to have the metal flashings, use a clamp to hold the metal onto the plastic pipe and seal the top of it with sealant. You could probably do a nicer job than this, but I don't know if you can see that yellow house. That's probably a quarter mile away, so I'm going to say no one's going to call you on it. Can't really see that unless you're standing right there. All right, any questions on any of that venting stuff? All right. Okay, so our standard for hose bibs is to use these frost-proof style. You guys probably know this. The actual valve is way back here. So when you turn the handle, it turns off the water there, and all the water drains out of the whole tube out towards the outside. And that way, there's no water out in the freezing zone of the wall or the bandboard area. And they don't call them freeze-proof. They call them frost-proof. We have had a number of clients cause these to freeze by leaving their hoses on them. So it's good to make sure that the clients know they have to take their hoses off in winter. Have you seen any other issues with those?
If they're not installed properly and it's pitched backwards, because that chamber's supposed to empty. Mm-hmm. Well, it won't. Of course, it won't empty if the hose is attached.
Right.
But it also won't
or
empty
if it's tilted the wrong way. That's a good point. Okay.
Yeah.
And this is something that's in our standard to do for larger projects. When you have a house with this many hose bibs, it's really nice to have them all in one place and have an easy way to drain them. So we put, we put a hose connection here that you just tie a hose into and run it to the sump crock or the laundry sink or something. And then they're all tagged. And this is a really nice way to manage a complicated house. We've renovated houses that have 10 hose bibs, and there are one's in this bathroom and one's in this mechanical room and one's here and one's there. And it's actually, can take you hours just to find them. This is a much better way to do it. Obviously, this isn't applicable if we're renovating a kitchen. We're not going to redo someone's entire hose bib system. And then this is one that Cameron did. He likes to use PEX lines for the hose bib lines because they're more freeze resistant, which I think is a great idea. Yep. Okay. Here's one we just ran into, and Tom, I apologize. You did such a nice job with this on the job that you just were finishing up, where you hid the pressure balancing valve in an access in the master suite, and I thought you did a great job with it, and I didn't take a picture of it, so I can't show it. But when we have a handheld sprayer on a tub, which almost every tub we put in seems to have, there has to be a separate pressure balancing valve almost all the time. And we got to find a spot for that. So usually we pipe it to the pipes to the vanity, or if there's an easy access under the tub, we can put it there. Or like Tom did, he made an access in a hidden area and put the valve in there. It has to be accessible for service later. Got any tricks for that?
You're talking about the mixing valve?
Yeah, well,
Okay.
So a lot of tubs don't have a pressure balancing valve, and in Maryland and DC, they have
Okay,
to.
right. Yeah, this looks like one that would have it. This is single.
Oh, it does? There you go.
But
Some
it's
of
the
them-
old
right, some of
school
them have them
two,
built
yeah,
in.
the old
Yeah.
school two-handled ones.
Right.
Then you would have to put that pressure balancing and a mixing valve for scalding
Right.
purposes. And there's nowhere to put it there, so you'd have to put it under a vanity cabinet.
Right.
Yeah.
Here's something that we run into. This used to be a great way for customer service to make friends. You'd go into a project that was just finished, and the clients would say, I just can't get our shower hot enough, and I would do this. I just yank the valve off, do an adjustment, put it back on, and we were best friends from there forward. But it's better to do that during the project. So all of the valve, or almost all the valves that we install nowadays, you pop off the handle, and there's this adjustment that limits how far the valve can turn, and that's supposed to stop you from scalding yourself. But it has to be set depending on the hot water temperature in the house you're working on. So it's a good idea to get a thermometer, run the shower, and make sure you're getting up to 108, 110, 112, just to be sure. Because sometimes the way that it comes from the factory, it won't get that hot and it's not comfortable. So there's another brand. This is something Cameron came up with, which I think is awesome. We put in 2 water heaters on a lot of our jobs for capacity reasons. And if you're clever, like Cameron's guys, you can pipe it with enough valves and connections that when one of them goes bad and starts leaking, you can just turn it off and they still have hot water. And then you're not scrambling around trying to find a new water heater today. You can come back in a couple of days and fix it. So that's a really good idea.
They have to be installed in parallel like that. It has to, both water heaters have to be the exact same size, same type.
Okay. I guess you could do it in theory. You could add the parts to do it and let them run serially, but we don't usually do that.
Yeah, you can't. It gets complicated.
It
but
does.
you can do that.
It does.
Yeah.
We can think it through. Go ahead, Larry.
We also sometimes have a gas, sometimes an electric. So the power is out. You have it so you can turn the electric one off. You can
Right.
have hot water.
Yep.
The generator.
Exactly. Yeah, so generally speaking, if you have 2 of them, run it so that, pipe it so you can turn one off. Same thing with wells. We even have houses that have 2 wells. It's really nice to have a well connection that you can bypass one and connect to the other one. All right, last item in this list. Pipes get full of sawdust and all kinds of other junk during the construction process. So before you stick the shower heads on, make sure that the guys have run the water for a minute or 2. Otherwise, you get a complaint about the 13-inch shower head that's supposed to feel like you're in a hurricane or something, and it's really just full of sawdust. And you don't even need to tell them about pulling the restrictor. So make sure we get that flushed out. Pull the aerators before we leave the job at the end. Okay. All right, let's talk a little bit about these materials that we have. Copper comes in 3 different grades, and we're using the middle grade, type L. It's the middle thickness. It's the same thickness as the fittings. Type K is thicker, but it doesn't seem like it makes sense to upgrade to that because the fittings aren't as thick as it. And type M is the standard for residential, but we've had enough pinholes and recirc line issues that we decided to upgrade to type L. So that's pretty standard. And copper supports 12 foot on center. The issues we've had with copper are when you have bad water, especially there's an area, Great Falls, where there's a lot of acidic water, and that'll eat through the pipes or recirculation lines, which we'll talk about later. So, and we've had a few bad joints, so it's a good idea to get the water test on as soon as you can and see if it'll hold water for a while before we turn it over. The other brand, or the other type of tubing that we use a lot of is PEX. Our standard is to use one of 3 sort of premier level manufacturers and to use all of their fittings. There have been some recalls and problems with off-brand fittings and off-brand tubing. So it's pretty important to stick with a quality brand on these. There's a couple of different ways to join PEX. I'm sort of laughing because this is just construction for you. Cameron made what I think is the right choice. He uses expansion fittings, which is in the top picture here. With an expansion fitting, you expand the actual tubing and slip it on the fitting, and then the tubing shrinks back down and grips the fitting. And you kind of can't do that wrong, right? There's no way to forget part of it. You can't make the connection without doing the connection. The other type is in the bottom picture. It's called a crimp ring. You put the crimp ring, the pipe, and the fitting together, and you come back with a tool and crimp it. And we've had 3 different times where somebody crimped 175 out of 176 crimp rings on a project, and then one of them blew off a couple months later. So you can do those wrong, and we have managed to do it. So I think it's much better to use the expansion fittings. The kryptonite for PEX is either a bad day at the manufacturing factory or leaving it out in the sunlight. The sunlight will dissolve the protective layer that stops chlorine from damaging it. And we did have a warranty issue with some PEX tubing, but the company came back and did not only replace the tubing, they actually paid for the entire repair down to the painting.
Right. It is the only time we've encountered a problem
Yeah.
with that manufacturer.
And that was really, that was a weird one because the water heater was having some issues. Like it was, like the temperature, the thermometer was broken.
Right.
It was running really, really hot. So it was putting very hot water through the recirc line. All right, another material is CPVC. Probably the most important thing with CPVC is to test it with water, not air. If you test it with air, it can burst and hurt people, so don't do that. I would say we're not in love with CPVC. There's a lot of things that damage CPVC. Oils, pipe dopes, caulking, fire stopping, spray foam, leaving a piece of Romex draped over it. The softeners from any of those things can damage the CPVC and cause it to burst and leak. So there's a lot of issues with anything that has that many things that can go wrong on a normal construction site. So I think we kind of steer away from it. But we do use it on some projects when there's already CPVC in the house. So it's important to know some other things about it, like don't do this. You can bend the pipe a little bit. There's actually a book that shows you exactly how much depending on the length and the diameter. But you can never set it up so it's stressing the fittings like this. That'll cause the fittings to break. We had to have the guys redo that. Another interesting thing, in most residential jobs, you wouldn't have to think about this, but a lot of our jobs, we have houses that are 100, 130, 160 feet long. So if you have a straight run of CPVC that long, it'll change size by 3 inches. And you have to plan for that. There's directions on how to do that. You basically just have an expansion loop or a change in direction so that the pipe can slide and not put too much stress on the joints. Because we work on a house that we didn't build it, but it was built by someone else. There's a run about 100 feet long from the mechanical room to the master, and they've had 3 leaks in it in the time that we've been working there. So I don't know where Adoni ended up, but he called me one day and I ran over and this is what was going on in their ceiling. So all in all, we just don't use it unless there's already CPVC in the house. Another material we use a lot of is PVC drain pipe. Kind of 2 important things with this is to use the purple primer, which most everybody does, but every once in a while you find a well guy or a pool guy who doesn't want to do that, and it's important that they do. Support it 4 feet on center. And the other important thing is when you're connecting to other materials, especially that black plastic piping, you can't glue it to that. You have to use the rubber connectors, the Fernco connectors. And we got bit by this really bad. There's one of the condo buildings we work in a lot. They have the black pipe in it, and we had a bad plumber try to glue PVC to it, and it cost us like $12,000 when it leaked. So let's not do that. On gas lines, there's 2 different kinds of materials: black pipe, the threaded stuff at the bottom here, and the corrugated stainless tubing, sort of yellow jacketed material going up vertically from it. So black pipe's the old traditional stuff. It's expensive. It's difficult to install. It's pretty strong, but we've had very good luck with the CSST. We've switched over to using this black jacketed material because the one thing that can happen with corrugated stainless is if lightning strikes it, it can burn a hole in it, and then it starts a fire right away because it's like if there's electric spark going through the gas. So now you're supposed to bond the pipe and use this black jacketed material. I'm going to skip that. All right, so let's talk a little bit about testing. We want to test our supply piping with air, but not CPVC, test that with water. One thing that has happened to us is the lines on the other side of the shower valves, like the line up to the shower head and down to the tub. If the valve isn't opened for the testing, you can have a leak in there and not know about it. So it's good to have those open. A few different ways to test drain piping. Just fill it up with water is what we normally do. But Cameron has a smoke machine that can fill the whole line up with smoke, and if there's any leaks, it'll make smoke come out. That's pretty cool. It's just expensive to run that test.
Yeah,
Yeah.
but you'll see the smoke come out of a light switch or something.
Oh, right.
And
then you chase it down.
And they've been annoyed by that smell for years.
Right.
You know, it's amazing.
And we
It's usually a vent.
We've also done peppermint test, which is pour some peppermint oil in from the roof and then walk around the house sniffing for peppermint. It works surprisingly well. It sounds silly, but it works really well. Very important to test showers, right? We want to fill it up to just below the curb and leave it for 24 hours. And it's pretty important to test your gas lines too. That's all on rough in. Then on final, this is something that I think we may have gotten away from on some jobs, but it's very important. On every job before we turn it over, we should fill all our fixtures up all the way to the overflow, let it run for a couple minutes, and then pull the plug and let the water run out. You know, when you do that, you find things like this little drip here from a cross-threaded pop-up connection. So if you don't do that, you might miss something. And you know, it's really easy for the drain connections to not be firmly set or whatever. We got to test all these. The other place that besides these pop-ups, on acrylic tubs, the plumbers don't want to crank the overflow really hard because it can crack the tub. So we got to test that. You got to fill it up and make sure that they did get it tight enough. And then a last step before we turn it over, we're going to make a map of the hose bibs and GFIs and whatever whenever we're doing a substantial renovation. Again, if you're just doing a kitchen, you don't need to do this, but for a substantial size job, this is really helpful. Clients really like that. Okay. All right, we're closing in on it. We got one more thing to cover, recirculation lines as promised. Yeah, this has been my unfortunate experience with recirculation lines. You see that little jet of water squirting out there? That was probably going for several days before it started pouring out of the ceiling. What happens in a recirc line is the scrubbing action of the hot water, particularly when there's anything off with the chemistry, like it's hard water or a little bit acidic, it literally wears away the inside of the pipes. So the thing to make a recirc line last longer is to reduce how often the pump is running and reduce how fast the water's flowing. So we want to reduce the flow. Otherwise, you're in this house doing this with a client who's mad because even though we didn't build the house, they've had 3 holes and it's just annoying to them. Yes, sir.
Since now there's the incident of cotton heaters that weren't around 20 years ago when we did more of these things in the big houses anyway, should we try to just dissuade people from doing recirc pumps at all? Just say they're sort of passe or you they're okay?
I think they're okay. I mean, the issue is when you have a really big house that's 150 feet long, unless you have like 3 heaters, it's still going to take a long time for the water to get from the heater to your fixture.
I'm just thinking we could use the master just to do it each state, the local ones.
Right. You could do that. You could do that. I actually think they should work fine if you take the 2 steps that we'll talk about right now. I mean, the issue that we've had is people, we would put in like a really powerful, macho recirc pump and just flip the switch, and it would run for 7 or 8 years, and then the clients would call us and they have 3 pinhole leaks in 2 months because we wore out the whole line. So we're not going to do that anymore. We're going to put in a small pump, and then we're going to use an aquastat, which is a temperature reader, to turn it off whenever it's hot and only turn it on when it gets cold. It's pretty straightforward, really. So there's Emilio getting ready to fix this one. What do? We insulate the line. That keeps the line hot. That's required by code. I put in here plumber, insulator, us. This is a new code thing, and people didn't used to do this. So the plumbers say, you want to pay me $150 an hour to insulate your plumbing lines? Okay. And then we say, oh, okay. We'll call the insulators and have them do it. And the insulators are like, you want us to insulate plumbing? So it's kind of a new thing. We've ended up insulating the lines a lot. There are professional pipe insulation companies. I know Mark's hired them on a couple of jobs. But someone's got to insulate the whole line, both the outgoing and the coming back. And then we're going to put an aquastat on. Now this right here is a non-adjustable aquastat, which is better than nothing. Whenever the water's above, this one probably is 135 or 125. I don't know. They come in a preset number. Whenever the water gets up to above the certain temperature, it turns off. And then when it gets back below about 10 degrees lower than that, it turns
it's
on.
going to be a little lower than the maximum temperature coming out of the water heater.
Okay. I gotcha.
Right, so it's probably going to be more like 120 or
120.
something.
Okay.
Yeah.
So the pump turns on, runs hot water through. As soon as the aquastat heats up, it turns off the pump.
Right.
And then when the aquastat cools back down, turns the pump on, it pulls hot water around the loop, but only like once. And that might happen 4-8 times a day instead of just running 4 or 8 times an hour every day, all day long.
Yeah, the other thing with that pump is you want the velocity to be as low as possible. So that I recognize that pump, it's got 3 different speeds, and you want to get away with the lowest speed.
This up here is the speed switch.
Yeah.
So you try the lowest speed, and as long as that works, you leave it on the lowest speed.
Right.
You can turn it up if you need to. Yeah, good call. We have tried timers on a bunch of things. This timer thinks it's 1:30 in the morning and it's 1:40 in the afternoon. And the clients had already pushed almost all the buttons or all the way around the dial because they wanted it to run most of the day. And then they ended up just switching it to on. So it's just running constantly. Same thing with this one. They pushed all the buttons and then they just switched it to on. So I've never seen a timer that clients were happy with, long story short. We even tried this. We tried putting in the battery backup, like outdoor light style timer, so at least it would keep the time correctly when the power was out. But the clients ended up just turning it on full time because their schedule varied too much and they didn't want a timer on their thing. So at the end of the day, the aquastat is the way to reduce the runtime. And I think the way to go with these is an adjustable aquastat because people change the temperature of their loops and you want to be able to adjust the temperature. In our plumbing standard, it calls out to use a Honeywell 4008, but any adjustable one is fine. All right, we've done it. Any questions for Cameron? Go ahead, Mick.
Just on gas lines, any thoughts on 2 PSI copper?
2 PSI copper for gas lines, does that work?
Yeah, well, that was what was used initially before corrugated stainless steel. So it's a lot of it out there.
Okay.
So, but there's not too many situations now that would be the preferable choice because it doesn't have all the flexibilities, options that the corrugated stainless steel has. We'll still use it sometimes.
Okay.
There's different different situations.
Is it as vulnerable to lightning strikes? Have you ever had
No,
it?
I mean anything can get struck by lightning. But does it? No, I think it's the corrugated. I think the problem with the corrugated stainless steel is it's very thin. You know, the copper's it's going to be type L copper.
Right.
But if you have to, on a short run, we'll use copper because it can be buried directly
Okay.
into the earth.
Good to know.
So I guess my question is, if there's an existing house with a 2 PSI system on the outflow, when you're adding a lathe to like a fireplace, what do you do?
Well, you can run 2 PSI through CSST.
Yeah.
Go ahead, Elmer.
I failed on my home project because that blackjack gas line was running up through an area, and he wanted these special flanges that went up past almost 4 inches. He said when you put crown in, a lot of times people are shooting through the gas line. So I actually
No
failed on
kidding.
that inspection.
Huh.
So WSSC billed me, so immediately they came back, put them on, and inspected the next day. It looks like a strike plate, but it's got a circle, like a round flange, so if a nail goes through, it deflects like the right over through the pipe.
That sounds great.
Yeah, so.
Yeah, we actually had a house last year, a renovation, and they had us put in a gas log. We turned on the gas line to that gas log for the first time, and they started smelling gas. A couple days later, someone put a nail through CSST, long before we ever got to the house. Yeah, that's a good one. So I guess one of our jurisdictions is saying to use a special extended nail plate, especially at a ceiling plate, so that when you're putting in crown, you can't accidentally shoot through the CSST.
Actually, anywhere close to the baseboard.
And at the floor. Yeah, that makes sense. That sounds like a great idea. Did I see another hand over here? Okay. All right, Cameron, thank you very much.
Sure.
That was awesome. Really appreciate it.